Hello, my name's Simon Bradwell from EBM Papst in Melbourne, and today I want to talk to you about high efficiency plug fans for air conditioning applications. And here we've got an example of an EC plug fan in an air conditioning unit. These type of EC plug fans are typically used either in refrigerative or air handling unit type air conditioning units. First of all, what is a plug fan? A plug fan is a backward curved centrifugal fan without a scroll. And you can see here from the unit how the plug fan positively pressurizes the whole of this planet. This unit actually has the air ducted from the ceiling, but it also could be ducted from the side or the bottom quite easily. This product is an EC plug fan. And what's EC? What does that mean? Well, EC is a motor technology. An EC is a permanent magnet motor with onboard electronics. This allows you to give the motor three-phase as well as a speed control line, such that you can speed control the product from 100% down to 5% speed. Now, typically EC products are getting used in a range of applications, from refrigeration to air conditioning to ventilation. And the reason is because of their high efficiency. To explain that, I've done a graph here showing the efficiency difference between an EC product and MEPS and HEPS three-phase motors. What I've done here is I've made it a like-for-like comparison and put a VSD on the MEPS and HEPS motors, and I've assumed that there are 7% losses in the VSD. Here you can see that the EC motor alone is between 15 and 20% more efficient than a standard MEPS motor with a VSD. So here we are with a smaller EC plug fan to show the benefits of speed control. First of all, with EC plug fans, you can apply the fan laws, which means if you speed control the product from 100% speed down to 80% speed, you get 50% power savings. That means that good and simple, accurate commissioning is a real benefit. And here's a simple way of doing it. Here on the control panel, there's a simple 0 to 10 volt control pot. And when I wind up that control pot, the fan speed increases. I'll just wind it back down again. This allows you to have proportional air balancing inside your system and easy commissioning. It also means that you can have full BMS control if you want to as well. So here's the old technology that the EC plug fan replaces. This is a belt-driven, three-phase forward curve fan. So let's look at the efficiency losses that are typical in this type of product. First of all, there's the motor, and I've talked about that previously, 15% losses. Then there's the belts. Between 7% to 15% losses during their lifetime is typical. Thirdly, there's the forward curve fan. The forward curve fan is less efficient than a backward curve fan just by design. It generates too much dynamic pressure, which is not useful for us in this type of application. Also remember the dust and dirt that comes off the belts. This can often be a problem in clean environments such as hospitals or something like that. So let's put all those energy efficiency improvements in the new technology together inside the air conditioning unit. First of all, there's the EC motor, the permanent magnet motor, which is more efficient. Secondly, there's a direct drive system. Thirdly, there's high efficiency control systems. And fourthly, there's the high efficiency backward curve plug fan. Now all of this together allows the air conditioning unit to run at much higher efficiency than the old unit. And let's take a case example of that. Here's the Supreme Court buildings in Adelaide, in which an EC plug fan air conditioning unit was installed to replace an old air conditioning unit. And on this graph, I've plotted the power consumption before and after, as well as the savings associated with the replacement. And as you can see, there's a 66% power saving with respect to using the new technology. That's 8.95 megawatt hours per annum. That's truly tremendous. So, in summary, here we have an EC plug fan inside an air conditioning unit or air handling unit. It's a much more efficient unit because it uses backward curve fan technology. Secondly, it's a direct drive system. Thirdly, it has EC, high efficiency permanent magnet motor technology, which has inbuilt high efficiency speed control. The product can be easily speed controlled to allow proportional air balancing or even allow full BMS connectivity if you require. In comparison to the old technology, we can realise 50 to 60% savings. And a good example of that is what's been achieved in the Supreme Court building in Adelaide, where 66% power savings, or 8.95 megawatt hours per annum, were saved by using the new technology and the new air conditioning units. If you want further information, please go to our website, ebmpapst.com.au or ebmpapst.co.nz, and look for further articles with respect to this type of technology. Thanks very much. I hope you've enjoyed this.